Okay, today we're going to solve a system of inequalities, and we're going to do it quickly. Try to do it quickly. So I have a system of inequalities, and the first one, 3x plus y is less than 7. I'm going to solve that for y. So y is less than 7 minus 3x. Put that in my calculator. Y equals 7 minus 3x. In order to solve the inequality, you need to first graph the equation. So I'm using my calculator to graph the equation. The next inequality is already solved for y. Y is greater than or equal to 2/3 x minus 4. And I can put both of them in. So y equals 2 divided by 3 x minus 4. And this is what the two boundary lines of the inequality will look like. If you want, you can have your calculator show you the shading. If you arrow over all the way to the left, you can actually change to shade, to do a bold line, to shade above, or to shade below. Since it says that y is less than 7 minus 3x, I'm going to shade below. And the next one, it says y is greater than 2/3 x minus 4, so I'm going to shade above. And when I go back to my graph, I see exactly what the inequality should look like. And I know exactly how to shade it. So when I go to second graph, I'm going to start by graphing the first inequality. These numbers are too high to fit on my graph, so I'm going to go down to negative 110. That's the first line, first point that I can graph, negative 1, 10. The next point is 0, 7, 0, and then I go up to 7. And I look for a pattern, 1, 4, and I notice that for every point I'm going down one space, down 3 spaces and over 1. Down 3 spaces and over 1. And if you look on my points, it's actually working out. I just graphed 3, negative 2. Down 3 over 1, down 3 over 1. I'm going to take my ruler. And since this symbol is a less than symbol, that means that my line is not part of my solution. So when I make my line, my boundary line, I'm going to use a dashed line, not a solid line. Very important. You could lose a point if you don't do that. So here is my dashed line. Okay, and I like to extend my line beyond my graph. I'll erase that little mistake right there and put arrows on the ends. And now if I look back to my graph, my picture, I'm noticing that this line right here is being shaded below, underneath. So I start shading, and I shade it just like this. I use lines going down towards the ground to shade in. This means that all of my solutions to this inequality are all these points on this part of the graph. So now I got to graph my second one, and if you notice, some of these points have some decimals in them. Decimals you cannot graph accurately, so I just skip them. Right? So negative 6, 8 is the first point I'm going to start with. So we'll use a different color. I'll use orange. Negative 6, 8. Negative 1, 2, 3, 4, 5, 6, and then, negative 6, negative 8. I go down to negative 8. There is a point. Then I skip over this point, I skip over this point, and I go to negative 3, negative 6. 1, 2, 3, and then down to 6, which is right here. And I'm going to skip over, and I'm going to find some whole numbers to graph. 0, negative 4, 0, negative 4. And I start to see a pattern. Over 3 spaces on the x-axis and up 2 on the y. Over 3 and up 2. To the right 3 and up 2. To the right 3 and up 2. To the right 3 and up 2. And I notice that my change in y is 2. And my change in x is 3. There's my slope, so that makes sense. My y-intercept is negative 4. There's my y-intercept. So I can double check to make sure I'm doing the right thing here. take my ruler, and now since it says that y is greater than or equal to, that means that the boundary line is part of my solution. So I'm going to use a solid line when I graph this. Now I look back to my graph, and since it says greater than, we see that we're shading above the line, and this whole area above this boundary line is getting shaded. So now I shade with lines going up towards the sky. So where the two solutions overlap, the two shaded regions overlap, that's where my solution is. So I can choose any point in this shaded area. It doesn't matter where. I'm just going to choose that point randomly. And then say that this, if I look at this point, that's negative 1, 2, 3, 1. So the point negative 3, 1 is part of the solution set. And I used words right from here. It's part of the solution set. It's a point in the solution set. If you do all of this, you'll get full credit on this question. Good luck.